reproduce Jupiter's moons. And I presented it in class as one of the things for talking about kind of the move from geocentric to heliocentric. And my student asked me a question and I answered him, but I'm wondering how else I could have answered him. So David, he asked how exactly seeing moons orbiting Jupiter disproved the geocentric theory. Why wouldn't the geocentric theory simply be adapted so that multiple bodies could have their own systems, but everything would still be around Earth primarily?
Well, and it didn't in exclusivity, but it was the, phases of Venus, inferior phases of Venus, and other evidence that led to the whole movement in support of Copernican theory. So it independent of Jupiter just looking like a miniature solar system, of course, wasn't enough.
My point to the student was basically that simply took away the specialness that they were claiming for Earth, the idea that only Earth could have things revolve around it. Once you see, it starts to open up the question of, are we missing or are we stretching our explanations too far to try to keep this model with all the epicycles and deference and everything?
Yeah. That's a good answer. Yeah.
That's great. I'm loving this part because the students, I mean, they know, they basically know the heliocentric model. They know a bit about this idea that planet orbits are ellipses, but the impact of it and the way in which it came about, when you go through the history, it really starts to shed some light on the way in which human nature works.
And there's that critical moment that comes later. Tycho was fooling around in various ways, essentially, but when it came to Kepler and mathematics really joining, there was a sort of a first brushstroke toward, you couldn't quite say astrophysics that early on, but a mathematical understanding of orbits and how they worked that led onward to Newton then.
It always throws them this idea that Tycho was actually a geocentrist and that he was sure that that's what the math would eventually show.
He partially bought into that, but he was very skeptical of Copernicus too, in a lot of ways. Yeah.
Well, I mean, the numbers just weren't working. It wasn't giving us any better predictions. Yeah. And that was one of the main critiques of the Islamic scholars on the Almagest, is that it just was not giving reliable predictions.
And finally, along came the Rudolphine tables and improved the accuracy of things.
I honestly, just history of astronomy would be, a multi-semester course if you had time to do it.
Oh, yeah. Yeah. And so detailed. You have to have people who are really interested in it, though. A lot of these kind of interstices in this era of the first or second millennium of since, last couple millennia, it gets to be pretty thick stuff for a lot of people unless they're really interested in history.
I find the ancient astronomy is something that this term is capturing the students more than the indigenous astronomy. So I've cut back a little on that compared to last term, where they really wanted to know all the indigenous stories. Last term, I ended up doing an hour and a half on just indigenous stories from across the world and connecting them to things you can actually see when you look up. This term, it's a different shift for the core. And I like that. I like the fact that the students have different ways of approaching the material.
Yeah, and different interests within that's a good thing. Gives you some variety as the teacher too, which is nice.
Oh, it never stops. I have to say, I love the part of the quote, "the nuclear waste from fuel that makes stars shine." For those that are cynicists at heart, think of ourselves as nuclear waste, just kind of speaks volumes. Scott, have you had a chance to say bye to Jupiter since it's leaving our evening skies?
I've been watching it move across the sky for months, so I just love, to see the planets move across the background of stars, week after week. And of course, the great conjunction, with Jupiter and Saturn was just mind blowing, to see how really fast it moves,
That was incredible. And I know Mars and Venus are going to be in conjunction again in about a week and a half or so.
Mm-hmm.
And I think in 2 weeks they'll be in conjunction with the moon again. And it's just right now getting the students to realize that things leaving the evening sky simply means they're moving to the morning. They're still there. It's kind of this neat little effect where they're like, oh, wait, yeah, that's true. And then some of them get up early in the morning before sunrise because it's late enough right now that they can do that. But in the summertime, it's pretty much just the evening skies that we concentrate on.
Right. I love this visualization. It just to be able to run these computer simulations of, with a lot of, I guess, the best observations in math that they can throw at it. It's just incredible what they're showing us today in this way. We're spoiled.
We are.
We're spoiled. And can you imagine what this is going to look like 50 years from now?
It'll be augmented reality. You can actually move into a star system and change the scale so that you can see everything move around you.
Right.
I mean, the technology is there now. It's just a question of figuring out which data to represent best and then having somebody with the time and energy to put it together. But it's almost going to become automatic processes, just like it is now, where often the data immediately renders images for you and simulations for you because that's the way you write the script from the start.
Yeah.
I mean, part of the question, though, here is when you have people with visual disabilities, how do you get this level of intricacy across to them? And sonification wouldn't do it because it's too one-dimensional for sonification. So you need to have other ways to represent this.
Hi, Carroll.
Good evening, David. How you doing?
Good to see you, Carroll.
Good to see you again. How you been?
Well, we're doing all right, but this pandemic doesn't seem to be ever wanting to end.
I agree.
But we're very glad that Scott is doing well now.
Yeah,
Scott's actually very happy about it too.
I bet you are.
Yeah. It wasn't horrible. It just was tiring for sure.
Yeah, it's
exhausting. Okay. I'm going to move along here.
Eta Carina is the most massive star within 10,000 light years. In the mid-19th century, a tremendous eruption hurled enough gas into space to make at least 10 copies of the Sun, creating an expanding nebula still visible today. New results from NASA satellites, ground-based telescopes, and theoretical models are providing astronomers with an improved understanding of this system. At the nebula's heart lie two giant stars. The smaller of the two is 30 times the mass of the Sun and 1,000,000 times brighter. The primary weighs 90 suns and shines 5 times brighter than its companion. Both stars produce powerful outflows called stellar winds, but the primary's is so dense it prevents astronomers from directly observing the star. The secondary's orbit is among the most eccentric known. Every 5.5 years, when the two stars swing toward closest approach, or periastron, they come about as close to each other as Mars is from the Sun. Eta Carina's most recent periastron occurred in August 2014, and many of NASA's space-based telescopes, as well as ground-based observatories, looked on. Where the stellar winds collide, temperatures reach hundreds of millions of degrees, hot enough to emit X-rays. But the X-ray emission shuts down near periastron when the smaller star is swallowed up by the dense wind of its larger companion. The X-rays gradually recover after periastron, but they do so a bit differently each time, suggesting structural changes in the dueling winds. Recent observations have helped theorists refine computer models of this interaction. Here, darker colors indicate lower gas densities around the stars, while the stars themselves appear as black circles. When the stars are far apart, the winds collide head-on, creating a huge cavity surrounded by 50 million degree gas. But near periastron, the secondary whips around the larger star, carving a tunnel through the primary's dense wind. The secondary star's rapid motion changes the collision zone from head to tail. The smaller star's faster wind flows out along the cavity it created and then crashes into the outward-moving wind of its companion. From our perspective on Earth, the X-rays fade, then recover as the stars move apart. New 3D models of these simulations reveal the formation of finger-like protrusions along the cavity near periastron, features never before identified. Theorists now investigating the phenomenon suggest they may arise from instabilities developing in gas as it flows along the cavity wall. Astronomers also keep an eye on Eta Carina with the Hubble Space Telescope. These images show a structure resembling a crab, formed by gas excited by the secondary star's intense UV light. This light dims near periastron when the secondary passes through the thickest part of the primary's wind. The gas relaxes, settling into a lower energy state. As a result, the crab appears in a different spectral line until the stars move apart and the UV light is restored. Eta Carina is one of the closest and most massive colliding wind binaries, and serves as a natural laboratory for studying these rare and important objects. While its past eruptions remain unexplained, astronomers think they have a handle on its current state, a claim to be tested at the next periastron in February 2020.
Well, hello, everyone. This is Scott Roberts from Explore Scientific and the Explorer Alliance, and welcome to the 81st Global Star Party. I have been out for a while, but it feels so good to come back and be here with my friends and be here with all of you to explore the universe together. We have a great lineup of speakers for you today. We are waiting to interact with you on live chat, and we have David Levy up next, David Eicher, Karim Jaffer, Carroll Orge, Jason Guenzel, and many more will be on tonight. So, but we will get started. Earlier, David was regaling us with a song about Vincent van Gogh, and it was a beautiful song by Don McLean. I wish that we could have played it for this particular Global Star Party, but we are kind of prohibited from doing such things because of copyright issues. But it really did help set the mood for the event. And, that's one of the things that David always does is he helps set the tempo and the mood for, I think, every event he goes to. We're blessed to have him attend all of our Global Star Parties, and, very thankful to call him a friend too. So, David, I'm going to turn it over to you, man. Thanks for coming on to our 81st Global Star Party.
Thank you, Scott, and welcome back. I think all of us can say that we missed you a lot. We're glad that your bout with COVID has not been that serious and that you are recovering well. And it's good to have you back.
Thank
Our
you.
star party tonight dealt with a very important star, Eta Carina. And I wanted to begin by saying that my friend Bart Bach, who was a very famous Milky Way astronomer, his favorite star was definitely Eta Carina. And at the opening of the Flandreau Planetarium in November 1975, he arrived early with his wife, who was quite ill at the time with Alzheimer's disease. And they went to the back room of the planetarium, and Priscilla stopped and she said, "Eta Carina." And Bart said, "Yeah, what about it?" And she said, "That's where I want to be. I'm going to be, after I'm gone from here, I'm going to be at Eta Carina. That's where the good Lord is cooking stars faster than anywhere else in the galaxy. And that's where I want to be." 4 days later, Priscilla had a heart attack and passed away. And I think we all like to remember now that both she and her husband Bart are now watching over us from the Eta Carina Nebula. I wanted to talk today about a different sort of artwork, not poetry, not prose, but art itself. Some of us were able to hear on the Zoom session Don McLean's very, very famous song, Starry, Starry Night. Actually, it's called Vincent, but you know how it all begins, Starry, Starry Night, and goes on and talks about how Vincent van Gogh had this really sad, depressive life. And when all hope was gone, he took his life as lovers often do. And the line that comes after that, I've never forgotten. It's just precious. The world was never meant for one as beautiful as you. And we can't play the song to you, but I can read a letter that Van Gogh wrote to his friend Bernard. He said, that same week, a starry sky, he wrote to Bernard, "A starry sky is something I should like to try to do. Just as in the daytime, I'm going to try to paint a green meadow spangled with dandelions." He compared the stars to dots on a map. Excuse me. And let's try again. To dots on a map. And he mused that as one takes a train to travel on Earth, we take death to reach a star. Although at this point in his life, Van Gogh was disillusioned by religion, it appears not to have lost his belief in an afterlife. He voiced this ambivalence in a letter to his brother Theo after having painted Starry Night, confessing to a tremendous need for, shall I say the word, for religion. So I go outside and I paint the stars. Back to you, Scotty, and thank you.
Thank you very much. Thank you. I love looking at Vincent van Gogh's paintings, especially, he seemed to me to be one of the few painters who love to paint the night sky, and it's so lively and interesting, that I think his own his own thoughts about the universe was that it must have been, utterly alive everywhere where he could see. So, but and the Starry Night painting is just one of them. There are many paintings that he did with the starry sky. So, okay, well, thank you very much, David. We are going to switch to another David Eicher, the editor-in-chief of Astronomy Magazine, another dear friend, someone that that I like with David Levy. I get lots of energy from, when we get into our conversations about things that are happening, things that we could do, in astronomy. I'm just very, very grateful to have friends like I have here, and it makes my experience in astronomy, I 100-fold over what it would normally be, I believe. So, Mr. Eicher, thank you so much. And I am going to turn this over to you, man.
And likewise, Scott, and we're all very happy that you're feeling much, much better. It's good to have you back.
Thank you. Thanks.
And I will see if I can share my screen. I'm going to talk about a little more planetary geology. I haven't run out of minerals yet, and I will start the slideshow. And can you see a big tanzanite crystal?
Yes.
Okay, well, I will carry on. Earth's universe of minerals. This is, of course, how the universe likes to make planets, by assembling atoms in minerals. And it's a universe of order. Thomas Jefferson said, I believe in a divinely ordered universe. Isaac Newton, even earlier, said truth is ever to be found in the simplicity and not in the multiplicity and confusion of things. And now, several centuries after each of them, we know that the universe is ordered not by supernatural design, but by the principles of physics. Minerals are nice in that they show how planets are formed. We know through spectroscopy that the chemistry in the universe is uniform throughout, and we have different local conditions, temperatures and pressures and so on, but we know of the same atoms that are assembled in certain ways, not by accident, but because of their properties. And we can hold minerals here on Earth and imagine that lots of planets out in the galaxy and in other galaxies are very much like, have minerals very much like the ones that we have as well. Minerals demonstrate that order. Their atoms are assembled in precise ways by electrochemical attractions, not by an accident or randomness. Inherent properties of the atoms that make them up and guide them into assembling in a specific, what mineralogists call a crystal lattice, when the atoms of the right type are together and so on. So tonight I thought I would talk about a couple that are fairly popular among human beings, gold and silver. They're both, we know now over the last decade or generation, a lot more about the origins of the elements. Gold and silver, among other precious metals, are some of the elements that are created in colliding neutron stars. Now, so when we hold a piece of gold or silver or jewelry that we like in our civilization, a lot of it's gold and silver, we're holding atoms that were created in neutron star collisional deaths, if you will. Gold, of course, the symbol AU, it was one of the first metals used by prehistoric cultures. It's the color is termed gold, of all things, and varies slightly with slight differences in the alloys of little impurities of other atoms that are in with the gold. The Old English word gold dates to about 725 AD. It may have been derived from the Anglo-Saxon word gold. The Latin name was aurum, thus the abbreviation AU. It's a member of the copper group of minerals, mineralogists term it, and it's gold is very valuable to us, and we treasure it, and it's not corruptible. It doesn't oxidize. It's very stable over long periods. It's not terribly super hard compared to some metals, but it's very stable. It if we could extract the dissolved gold, for example, that is in seawater on Earth, gold would be completely worthless. But there's a catch, we can't. So it's something that's hard to find in a metallic form, and that's one of the reasons why we treasure it. It occurs in hydrothermal quartz veins, in volcanic sulfide deposits, and in unconsolidated placer deposits, the way it's easy for us to get gold, although it takes a lot of searching, as culture has shown us. The crystal structure of gold is like some of the other minerals we've looked at recently. It's isometric, which is a fancy word for cubic. And here's a crystal lattice diagram of gold. And then one of its friends, silver, another precious metal, the native element, its symbol is Ag. It's used for many, many, many things. These were two of the earliest metals that were worked by humans on Earth. It's used in everything from tableware to jewelry to coins, scientific processes, photographic processes. Its color is silver black, and unlike gold, silver is very prone to oxidation. So it oxidizes to dark gray or black. The Old English word silver was the origin. The current silver dates to about the year 1478, and the abbreviation Ag derives from another Latin term for the substance, argentum. It's also a member of the copper group, and it also occurs primarily in hydrothermal veins. And so it sends those who are seeking their fortune, as we can read about in the Old West in the United States or many other places in human history, on scurrying hunts for valuable veins throughout the quartz and other rock. Crystal structure of silver is also isometric, so it has essentially the same crystallography as gold. There are variations, of course, here, but this is the basic for both. And I thought I would just show a few examples of some pieces from my collection. Gold and silver is very easy to find, mostly at something that is going on right now and for the next few weeks in Tucson, Arizona, near where David is, the Tucson Gem and Mineral Show, which is along with one that's held in Munich, the biggest show on Earth for collectors. It's hard to get into these places, as it wasn't 100 or 200 years ago, and find specimens of this stuff. Now lawyers are worried about people falling down mine shafts and never being heard of again. And so these are all sort of off access the mines now, abandoned mines. And so you need to go hunting for these things at gem and mineral shows. So Tucson right now, if you're in that area, that's the place to be. This is a nice crystallized gold on quartz. You can see that this is how it crystallizes in a vein of quartz from Placer County, California, that old mother lode area in California. Here is a crystallized sheet of leaf gold, and you can see, if you look very closely, I didn't take microscopic photographs of this. This is a piece that's about 4 centimeters high or so, but you can see there are tiny little trigons. They're little triangular crystal octahedrons and other shapes of the gold, how it crystallized there, almost like a feather. This is from a very famous mine called the Round Mountain Mine in Nevada. This is an old piece from my father's collection from many years ago, from the 20s or 30s, from a very famous mine, the Homestake Mine in Lead, South Dakota. Does anyone know why the Homestake Mine is very special, not just to mineralogists, but to astronomers? No?
No.
Well, now for many years now, since it's a defunct gold mine, there has been a neutrino detector in the Homestake Mine.
Oh.
So they've thrown it over to the cosmologists now from the mineralogists.
Interesting.
Here's another piece that I got from a Colorado dealer of minerals. This is a very famous mine, the Camp Bird Mine, a very famous gold and silver and other minerals from Ouray, Colorado. And this was a piece that was cut and held onto and found in a miner's bag that was discarded. I mean, you can see little bits of gold here. Well, the miners were always trying to make off with so-called high-grade pieces that they hid in their bags and their boots and so on. Sometimes it worked. This is a piece of, now calaverite is a gold mineral, but it's a gold telluride. It's made up of gold and tellurium. And that's one way that you can find a lot of gold in the Colorado deposits of gold as a gold telluride. My father, being a chemist, and he found this piece out in Cripple Creek, a very famous mining district in the 1930s. And he took he cut this piece in half, as you can see, and the original untreated piece is on the left, and you can see on the right side, he roasted that piece, and that bubbles out the gold. You can see some little bubbles of gold in that piece that the heating created to make more visible in a gold telluride.
Interesting.
Here's from another very famous Colorado mine, a little piece on quartz, the Little Johnny mine in Leadville, Colorado, one of the most famous and storied old gold and silver mining towns, up in the Themthar Hills west and very much higher up than Denver. Here's a very nice piece of sort of spongy gold. This is a large piece. It's about the size of a football with this spongy gold from the Olinghouse district in Nevada. This is a more recent find of gold.
When you say it's spongy, I mean, if you were to touch it, is it?
It is.
Does it have a
somewhat-
spongy feel to
You
it?
have to be now pieces like this and these guys are pretty durable.
Yeah.
Even though gold is a reasonably soft metal compared to this is quite fragile though. This
I
piece
see.
here. That is, they're almost like little spongy needles covering a fairly large piece. So this you have to be very, very careful with. You wouldn't want to shove your fist into this, or you would lose a fair amount of its value.
Interesting.
Now we go on to just some little examples of silver, native silver. This is the so-called wire silver. This almost looks like a little boot, this piece here, and it has a silver mineral called a canthite. That's a silver sulfide mineral, and some white calcite and so on too. There's a lot of silver in a region that has come out relatively recently in the last generation in Morocco, this area. And you can see this way that this silver crystals grow in a wire crystal habit here often. Here's a Mexican piece of silver, and this is this sort of herringbone crystal habit. Now the crystals are growing up cubically, but they're growing out and losing, running out of material to make more cubic crystals on a very small scale. And so it can create this sort of fishbone look that again has some calcite with the silver there. Here's a wire silver examined
Wow.
boulder piece that is from a very famous mining district called Freiberg in Saxony in Germany. This is one of the oldest examples of silver that exist as mineral specimens are from the Freiberg district here. This is the oldest silver mining region on the planet. This is going back to Morocco now, and this is a big piece that is about 1.5 feet high. And you can see that there's a piece of country rock on the bottom there, and then this kind of big hand of flat piece of silver is sticking up off of the country rock here, is embedded in the rock. And that's a big piece, larger than a couple of hands, of this very thin crystallization of a flat sheet of silver. This is from a famous Canadian silver, the Cobalt district of mining silver and other metals in Ontario. And this is a piece where there's massive native silver in this piece. You can see the silver pieces with a little bit of other impurities of stuff in there that's darker colored. And this is a piece that's actually sawn to reveal the silver in a solid block here of nearly all silver. Then this is a popular silver mineral. You can see the nice little crystal shapes in this. This is a canthite, which is silver sulfide, again from that Moroccan area. Just showing you some different forms here. Back to Mexico, a famous area called Zacatecas. Mexico, has a lot of silver minerals. And this is pyrargyrite, which is a silver antimony sulfide. And you can see the unusual crystal habit there.
Mhm.
And here is silver. You wouldn't want to grind this up and have it at your dining table, this piece. This is native silver crystals, very, very fragile, wire-like crystals growing over this country rock, which is arsenic, native arsenic. So you have to be careful handling some of this. But in Saxony, Germany, silver occurs intermixed with native arsenic often as well.
Wow. Wow.
And that's it. Those are some examples of gold and silver, just to show you that kind of range of what samples and specimens look like. And again, I will shamefully mention that Michael Bakich and I are coming out with a kid's book about space exploration. Still months off in the fall, but it's ready to go. So thank you. Back to you, Scott. Thanks for having me again. I will stop the screen sharing and throw it back to the head man, and we're glad to have him back this week.
Yes, we are. But David, I didn't see the gold chain that rappers use. I was looking forward to that.
I tell
You
you what,
did say herringbone though, so I found that interesting.
now, if you're embarrassing me, because now I almost feel like I have to mention this. It's not. It's a meteorite bracelet, but I have a special friend who's a rock and roll guitarist who sent me a very fancy meteorite bracelet. Now maybe next week I'll have to bring that on. And
Yeah, you
show
have to wear it.
Yeah, looking forward to it.
I have to say, the physicist in me was really happy to see the crystalline structure comments about gold and silver, because that's why those were the two that were considered for the James Webb Space Telescope, because that crystalline structure gives you enough free electrons to be really reflective to infrared waves. And so it's great to see that they have that's such a commonality in structure.
And John Mather would say, shame on you, but can we just have a moment of silence, of relief, that the Webb telescope deployed in the most complex way ever successfully? Wow. John
It's
said,
amazing.
no problem. It's going to happen just like that. The last 5 years he said that, and he was right.
Yeah. This is a Gibeon meteorite that I have. I've shown it to you before.
Nice. Yeah.
And it is my wedding ring.
Uh,
I just wanted to show that to you, to
Hey,
everyone.
David, pull it back maybe just a smidge far away from in there. Maybe it's in a little bit better focus. There we go. Yeah. Yep. Excellent.
Yep, I can see it.
And
I
that's
think I've seen the ring before. It's got like crystal structure.
It's Gibeon,
in
yeah.
it too, right?
Gibeon is
Yeah.
not only very dense, so it cuts very well to make stuff
Yeah.
out of, but it shows that you beat me to it. It's got that Wiedmannsstatten pattern of the crisscross pattern, and that only occurs in iron nickel that has taken a couple of 100,000 years to cool, which
Wow.
creates that strange crystallization pattern, the Wiedmannsstatten pattern. That does not happen with native iron on Earth at all. So that's a
Very
distinct
interesting.
signature of meteoritic
Yeah.
iron.
Puts my rubber active wedding ring to shame. I need to I guess I gotta wait a couple
Rubber
thousand
wedding
years so I
ring.
can have one like that. And mine's not made of crystal, unfortunately.
David, before I let you go, I just wanted to touch on Astronomy Magazine as well, and what's coming up with what's in the current issue at this time.
Oh gosh, I'm thinking about issues at the end of 2022 now that I'm planning. We have a big story that's just about out from this Bakich guy, planning for the 2024 eclipse,
Okay.
which is only 2 years away now. That's going to be the most viewed eclipse in history. unless, God forbid, we shouldn't even say that it would be clouded out the whole US, but
Right.
there will be 115 million people in the path of totality.
So
Could be
more people than the 2017 eclipse?
That's right.
Yes.
Because it goes from Mexico through Texas, through the Ohio Valley and up the eastern seaboard. So
Right.
many more cities are in the path. So that's very exciting, and not too early to start planning for the eclipse 2 years from now. We
We've
have a
started
lot-
planning already in Quebec as well. I mean, we've got it passing straight through the city here in Montreal and
Wow.
straight into Montmegantic, even our dark sky area. So
Wow.
we've had a committee
wow.
of all the local institutions, the schools, everybody who's involved in outreach getting together to plan out a whole strategy. Because this is the right time to get people to look up, is because there's something big coming. And like you said, knock on wood about weather, but even if it's not here, we'll be able to share views from all across.
Absolutely. Yeah, let's hope for
Also,
good weather.
also keep going, David. Go ahead.
No.
Well, not only good weather, but let's hope that the social and actual all parts of the pandemic by 2024, I think it's projected that we would be beyond all of it. We'd be back to readjusting to a normal life. And what better way to kick it off by getting people together to witness a total solar eclipse?
Oh God, I sure hope so by then. Yeah,
I hope we don't have to wait that long.
Yeah, before 2024,
Well,
I hope.
Yeah,
But,
well, here in the States, we're trying to push it a little bit further forward. Today was the first day back in the office for me. So, that's the United States. I know different countries are carefully moving forward in their own ways to, navigate where we are right now with the pandemic. So
Yeah.
with that note, I'll go back on mute so we can go back to talking science and astronomy.
Well, we've got a lot of science coming up in astronomy as well. And the cat is kind of out of the bag on this, so I could mention this. A few issues from now, we're going to have a very special issue that's never been done in any publication, that will be an entire space art, the state of the art of space art issue. Years ago, astronomy was very much noted for space art. The imagery that we have is a lot better than it used to be in the 1970s now, but still space art can take you to places. As Steve Walther, the magazine's founder, used to say, man's dreams of worlds unseen can take you up close to a neutron star collision or to floating strange things in the atmosphere of a gas giant planet or wherever. So we're going to have a space art extravaganza coming up that's in conjunction with the IAAA, the Association of Astronomical Artists. And that will be very, very special coming down the pike.
That's great. Well, I want to mention that space artist Michael Carroll sent me a number of books. This one is Drifting on Alien Winds. He did a number of books on with Springer as the publisher, and each one of the books that he sent to me, he made a very, he signed them and put some nice little illustrations in them. There's that one.
Nice. That's great.
So I'm gonna have to dig into these books and check them out. Here's another one where you can see, nice illustration. This is Lords of the Ice Moons, scientific novel. Plato's Labyrinth is another one. All these illustrations are done by Michael Carroll. And so dinosaurs, ancient Greeks, and time travelers. What more do you want? So
he's a longtime friend. He's a great guy. He's one of the great artists in the world of space art and has been for decades. Right. And he's a longtime astronomy author. He has a story coming up as well down the pike about eyeball planets in astronomy, which are these two planets that have completely different sides because they're tidally locked. So there's a Mike Carroll story coming on about kind of down the pike about that as well.
But some of these illustrations, that is classic Michael Carroll illustrations right there. So realistic, yet seen from perspectives that we'll probably never actually get to experience ourselves. So it's very, very cool. And I wanted to give him a shout out on that, and you gave the perfect segue for that. So thank you, David. That was great. So Thanks. And the specimens that you showed today were beautiful. I think everybody was like salivating, especially over those gold specimens. So,
well, thank you. And you know, we have one real problem talking about all these things we love to talk about. Going back to Douglas Adams, space is big, really, really big.
really,
So
really, really big.
We'll always need astronomical art to show us those places that we're never going to see up close.
That's
and
true.
that's kind of a good thing that we have that then.
That's true. Well, great. Thank you so much. Thank you.
Thanks, Scott.
All right. So up next, we will go to the Astronomical League. The Astronomical League does the Global Star Party door prizes, and they do that with a series of questions that are generally multiple choice. And Carroll Orge, the president of the Astronomical League, is here with us today. He has been with the league for, I think, over 20 years, something in that range, maybe even longer than that.
Lost count.
And lost count. That's right. And, the league is largely made up of volunteers. There's not, there's no big salaries. But they're big in their commitment to amateur astronomers. They're big in their commitment to education in astronomy, and with a federation of over 300 clubs and over 20,000 members, they're one of the biggest things going on in the world of amateur astronomy today. So, I got to see Carroll live in person here in Northwest Arkansas a few weeks ago, maybe a couple of months ago, and so that was very nice. And
nice to get out in person and see some of our fellow astronomers.
Yeah, that's right. That's right. So it was great to watch Carroll hand out some amazing Astronomical League awards. So I'm going to turn it over to you, Carroll.
Thank
Thanks.
you, Scott. Great to be here after a couple of weeks off, and glad to hear you're doing so much better, Scott. A lot of exciting things we've been discussing tonight. A lot of things coming up in the next few months, and so that's always good. There's always something to look forward to in astronomy. And I'm going to share my screen and give away some door prizes, or at least look at some answers. Okay. My window out of the way. Here we go. Everyone see it?
Yep, perfect.
Okay. Here's a warning we like to put out in the first screen. If anyone wins a door prize that's an eyepiece, an optic, we want to make sure that they're using the proper precautions as far as not looking through instruments without some filtering if you're looking through a telescope toward the sun. So 2 weeks ago, we had the January 11th GSP, and we had some questions from that one. Here are the answers. Number one, this 72-inch telescope held the record as the largest in the world for 72 years until the 100-inch at Mount Wilson went into operation in 1917. In what country is this 72-inch telescope located? And the answer is Lord Rosse's Leviathan of Parsonstown is in Birr, that's B-I-R-R, Ireland. Okay, that was answer number one. Number two, this is the second largest moon in the solar system. Is it Earth's moon, Ganymede, Titan, or Charon? And the answer is C, Titan. Then we go to number three. This galaxy, and that's GN-Z11 in Ursa Major, this galaxy is a record holder. What record does it hold? Is it the furthest known galaxy, largest known galaxy, furthest companion of the Milky Way galaxy, the fastest rotating galaxy, or host to largest black hole? The answer is furthest known galaxy. Okay. And from that January 11th session, we had several names, some very familiar names. They're on here quite often. Cameron Gillis, Adrian Bradley, Lubomir Taliga, Rich Kralin, Josh Kovac, Rich Eubank, Mike Overarcher, John Keogh, and let's see, so Andrew Corkle, and
Ellie Letourneau.
yeah, there we go, and Kelly Letourneau. Okay, and then the winners for January 2022 are Rich Kraling, Andrew Corkill, and Kelly Letourneau.
Great.
All right, and then the questions for tonight. And send your answers to the questions just as soon as you can to AstroLeague secretary at astroleague.org. Question number 1. Who was the founder of the Greenwich Observatory in England? Who was the founder of the Greenwich Observatory in England? Question number 2. Which planet in our solar system has a year that lasts 84 Earth years? Which planet lasts 84 Earth years for their years? Number 3. What is the fastest rotating planet in our solar system? The fastest one as far as rotation. And again, send the answers to secretary at astroleague.org. And a few weeks from now, on Friday, February 18th, we'll have the next Astronomical League Live for the month. And leading that will be John Goss, a past president of the Astronomical League. And he's got a fascinating title, All is Change, Amateur Astronomy from Impressionism through Postmodernism. Sounds like a fascinating topic, and you want to tune in for that. We hope to see a lot of you there. The main gang will be here from the league, as well as Scott, David, and Molly, one of our imagers. And then coming up, we've got some other things involving, whoops.
Yeah, the 2022 Alcon.
Right, that's coming up, and we've checked with the local folks in Albuquerque. Everything looks good as far as the state. They are gradually relaxing their requirements in New Mexico, so we're confident that it's going to happen. Year 3, we've been trying to do this, and it looks like this is going to be the magic year. They've been very patient. They've hung with us, so we're looking for it to see what a great feeling it is again to have a group of astronomers together in person. Zoom is wonderful, the media in various forms, but it's not quite like getting together. So that's coming up next. Scott, back to you, and I'll quit sharing my screen here.
All right. And here we go. I can help you out with that.
Thank you.
We are. Yep. I do want to add that, and I did put the link in into chat there where you can go and join the Astronomical League. You can join the Astronomical League through a club that is known as an Astronomical League club. There's over 300 of them in the United States. But you can, if you live outside of the United States, you can join as a member at large. And so that is something that you can be, you can get involved with. They have amazing observing programs, amazing awards programs. And if you've never been to an Alcon event, you definitely need to go because their keynote speakers are usually of mind-blowing quality, and it's always fun to go there to meet up with friends and to be there with your peers.
One of the special trips is going to be a trip to the Great Array there the large array.
Yeah.
On the Sunday following the convention.
Oh, the VLA.
Yeah,
Wow.
that's
Okay.
a very special trip they've got planned.
That's awesome. That's awesome. Well, great. Well, Carroll, thanks for joining us today. And we will see. Do you already know who's coming up next week for?
I don't remember. Let's see. That will be John Goss.
John Goss. Okay. All right. Wonderful. Okay. Carroll, thanks again. Take care.
Thank you.
Okay. So let's see. We are moving on to the Montreal Center Royal Astronomical Society of Canada, and with Professor Karim Jaffer. We are, Karim is a great professor of astronomy and an amazing outreach ambassador. And so the RASC is very fortunate to have him be part of that. So let's see, you've started sharing before I could switch over to you. Let's see, let me get out of here.
Sorry, Scott, should I stop and start again?
No, you're good. You're good now.
Awesome. Thank you very much. Thanks for the introduction and welcome back. As everybody's been saying, it's great to be back at the GSPs, but it's more important to see you online again. It's been wonderful to see you just pick up where you left off. I see you online all the time on Facebook and on YouTube and on explorescientific.com/live. And today's topic, we've got Forged in Stars, and I decided to take a slightly different tangent at it. And when you have something forged in stars, you tend to end up with stellar forges as well. And so I'm going to get us towards looking up at stellar forges over the next few minutes. But before I do, I wanted to just touch on a couple of quick things. And the first thing that I did want to touch on is the James Webb Space Telescope, which both David Eicher and I mentioned earlier. It has reached its orbit in L2, its halo orbit, and it successfully reached it. They've also talked about the first target that they're going to be using for calibration, which is up in Ursa Major. And so I was happy to share that with my class today and talk a little bit about the whole calibration procedure. But the one thing that I did want to mention that's not quite as happy-go-lucky is today is the 19th anniversary of the Columbia disaster. And it's the third of our space exploration unfortunate tragedies that we had. Apollo 1, the Challenger, and then the Columbia on reentry. And it really is kind of a sobering moment to remember that, with exploration, there are risks involved. And so as we start to look back to return to the moon, that's something that we do want to keep in mind, is that we are putting lives on the line every time we take off in a rocket, whether it's Dragon or whether it's Soyuz, to go up into Earth's atmosphere or go further. We are very much counting on these astronauts to take those risks for us. And we all waited with bated breath for the last month as James Webb made its way out there in a whole automated sequence. But we felt the risk. All of us, no matter whether we were scientists involved in the mission, whether we were amateur astronomers just trying to capture a little glimpse of James Webb passing through the night sky, we were aware of the risk of what would happen if it didn't quite deploy properly or if it didn't get there. We've talked about it at the star parties over the last month and a half. But it's amazing how we all get to share that journey and we get to share that experience. A lot of that has to do with outreach. So I do want to do a brief check-in with some of our outreach partners. And I want to mention that Astro Radio, and especially the Reach Out and Touch Space panel that I'm on, is still recording every Monday. It's 8 p.m. to 10 p.m. British time, which is starting at 2 p.m. Central time. And I'm so happy to say that on Monday, February 7th, our guest is none other than our own Scott Roberts. So we'll be chatting with Scott about all the amazing work that he does. And the panel is just looking forward to hosting him and having a nice conversation about just outreach overall, but also our own individual journeys into astronomy. At the RASC Montreal Center, we just had a fantastic event a week and a half ago, on celebrating the 30th anniversary of Dr. Bondar's mission into space aboard the Discovery. Our next event is coming up in just over 2 weeks. It's going to be celebrating the first year of on Mars of the Perseverance rover and the Ingenuity helicopter. So we have one of the scientists who's actually a PhD candidate at McGill University, Erin Gibbons. She's part of the rover operation team, and she helps to operate the SuperCam science laser that does the actual chemical analysis of rocks. So she's going to share with us a lot of what she's learned so far over the first year and what's next for Percy. And anybody's welcome to join bit.ly/Percy 1 year, and you can register for this Zoom webinar. I'm also very happy to report that the Junior Astro League that David Levy has talked about a few times is now up and running. It's an initiative of the Denver Astronomical Society, and our RASC Montreal Center has been helping them get up and get going. And our first event is coming up on Sunday, February 13th for youth ages 10 to 17. If you're a kid aged 10 to 17, or if you know kids aged 10 to 17, they do not have to be members of the Denver Society, of the Montreal Society, or even of the Astronomical League. They can join us from anywhere in the world. It's from 2 to 4 p.m. Mountain Time on a Sunday, and it's going to be led by my daughter, Tara, and she's going to be talking a little bit about extremophiles and what we believe alien life might look like, and then, of course, how to sketch it. And that art component that David talked about that really captures the imagination and allows us to look at what we wonder and what we imagine things will look like when we eventually get there to observe. That's something that's amazing in kids. And so we really want to see the kids' creations, and we hope to share them with you at a future Global Star Party as well. I also want to mention it's the Chinese Lunar New Year, right? It's 2022. It's the Chinese Lunar New Year. It's the year of the tiger, which is the third in the Chinese zodiac. And it's based on that famous legend of the race of 12 animals, and the tiger ends up third. And it's a fantastic story, and I highly encourage you to read that tale of competition amongst these different animals and how the rat managed to win. I just love that. But the other thing to note, that this idea of a lunar new year and a lunisolar calendar is not something that's particular to Asian cultures. There's many different cultures across the world that celebrate a lunisolar type of calendar. And in fact, even in the Aboriginals, the Hobi celebration in British Columbia is based on the first appearance of the crescent moon in February, because that first crescent moon that's going to come up tomorrow night, it has this look of like a scoop, the waxing crescent that's very, very thin. And they actually refer to it as the celestial scoop. So this tradition of a lunar new year based on the lunar cycle and fitting 12 or 13 lunar months and having the calendar shift accordingly is something that's shared by many different cultures, both cultures from across the seas as well as indigenous cultures right here in North America. It's also the start of the next lunar month. And so this is the snow blinding or the snow hunger month. And depending on whether you're looking at it from the Mi'kmaq or from the Algonquin perspective. And I can't pronounce the name very well, Apuknajit, but you can always look at the Mi'kmaq Moons videos on YouTube. The tradition is basically, this is the hunger month. It's the month where the spirit of winter is the hardest. It's the hardest for gathering, for surviving, for finding food. And so to appease the spirit of winter, there's typically these celebrations done on the first night to invite safe passage into spring. And we also see this manifest in, of course, Groundhog's Day here in North America. And we'll be celebrating that tomorrow and hoping that Puxatawny Phil and Wyerton Willie get to see their shadow, or don't see their shadow in this case, because we really want an early spring. Mentioning all of this, I have to kind of harken back to the constellations that we look at when we look up in the night sky. And we've talked previously about the winter hexagon, because that's really the thing that we look at most prominently in the wintertime. We have this beautiful picture by Adrian that he shared with us all the way back in the fall of the winter hexagon, or the football, if you want to call it that, with the Super Bowl coming up. And you can clearly see the beauty of the Orion belt, the nebula there, Betelgeuse and Rigel. You've got Sirius, you've got Procyon, you've got the Gemini twins, you've got Capella, you've got Aldebaran. You can even see the Perseids there beautifully in this picture. And I share this with my students to give them an idea of why dark skies are so, so important. And if you go outside of the city of Montreal and you go into rural Quebec, you can sometimes get some beautiful night sky views. And this view here was taken by one of our local Montreal astronomers, Francois Guenzel, And he was happy enough to share this with my students and allow me to share this on his behalf for the outreach tonight. And it's just wonderful to see what you can capture with wide field photography. And so what I have my students do at this time of the year is I have them go out and do a globe at night activity. And the globe at night activity right now is to try to see Orion and figure out how many stars you can view. And if you have reasonably okay suburban skies, you can try to capture a little bit of the constellation. But if you're in the heart of the city, you can see those brightest stars and you can see the Hyades, but you can't see the shape of Orion. So it's really hard to know what you're seeing. But if you do manage to get into slightly better skies, like what I have here in the suburbs in Beaconsfield, Quebec, you get to see the belt. You get to see all four of the core stars surrounding Orion, and you can see several other stars in that region. And then if you're able to get to dark enough skies off island, all of a sudden the number of stars start to pop. And it's really hard in some cases to figure out which ones are the Orion constellation because there's just so many stars out there. And so the Globe at Night website encourages during week and a half periods every month to look at specific constellations and try to identify how bad the light pollution is or how good the light pollution the lack of light pollution might be in your specific area. And so I have my students go and do that. Unfortunately, we have had nothing but cold. And on the few days like this coming Wednesday and Thursday, when there's not minus double digits in Celsius at night, it's snow and wet snow and clouds. So I've managed to extend it by a month because in the end of February, start of March, they're repeating the Orion Nebula the Orion constellation one more time. But I had a couple of students go out and do the imaging nonetheless. Chloe got this beautiful picture in suburban skies using her iPhone 11 in night mode. And she was really happy to see that not only did she get the Orion constellation really nicely framed by the trees, but if you zoom in, you can actually see just a touch of the nebulosity around the Orion Nebula itself in the sword. Michael and two friends, Zachary and Tristan, they had gone out before the semester even started, and they'd managed to get into darker skies outside of the Montreal area. And so they had taken a picture of Orion just because it was a beautiful night, so they wanted to take a picture. And even with the wispy clouds, you can still see so many more stars when you get out of the city into the urban areas. And I'm happy to say that tomorrow in lab, they're also going to get to work with RGB filtered data from our remote telescope to try to put together their own picture of the Orion Nebula, such as Maxime and Alex did this past fall here that I'm sharing with you. So when we're talking about forged in stars, when you have stars explode, they leave behind a nebula, those can create these beautiful new birthing areas for new stars. And the Orion Nebula is one of the most studied ones for us. And so that's where I take my students early on in the term. So that's what I wanted to share with you today, a little bit on a check-in, as well as a little bit of what the students get to do over the next little bit. Scott, back to you.
Thank you very much. Before I let you go, I would like to also have you talk a little bit about the RASC and how you can get involved.
Yeah, so the RASC has 29 centers across the country, pretty much every major city in Canada, and several of the smaller cities that have academic institutions or just have a very large gathering. They have RASC centers. So you can look those up on rasc.ca. You can also just join as a national member, but our Montreal Center actually has international members as well. Chuck Allen's a member, Pete Williamson is a member, Adrian is a member over in Sarnia across the border from him. It's really a society of not just passionate astronomers, but also hobbyists and educators and outreach specialists, scientists, astrophotographers, pretty much everybody from across the spectrum of the hobby of astronomy has a place at the RASC. These days, a lot of what we're doing is by Zoom, just like it is for most of the centers across the world. But what we've been able to do is we've been able to really harness this with Zoom activities that bring centers together. So our Wednesday clubhouses, we will often have a member from Ottawa, somebody from London, somebody from the East Coast, somebody from the West Coast join into our conversation to talk about what we see in the night sky. And so locally, we're over 170 members. Across the country, we're at about 5,000 members in 29 centers.
Very impressive. Yes. And how old is the Royal Astronomical Society of Canada?
We're about twice the age of the Astronomical League. We're 150 years old nationally. It started as a club in Toronto back in the late 1800s. And our Montreal center actually is now 104 years old. So, we're showing the gray a little bit. We have a dark sky area that is actually a member's farm that she lets us set up at. We also have an observatory in the darkest skies that we have on the island, which is Morgan Arboretum, run by McGill University. And then we have an astronomical library at my college, John Abbott College.
Wonderful. Great. All right. Well, thank you so much, Karim. That's great.
Thanks, Scott.
All right. So up next is Glenn K. Roberts. Glenn, I don't know if we're cousins or some sort of relation, but Glenn, if I'm correct, you are also a member of the Royal Astronomical Society of Canada. Is that correct?
Yes, that's true. Yeah.
Right.
And just before we get on further, Karim, I used to live in Bay Durfee, Quebec.
Oh, excellent.
Yeah.
That's just between where I am and my college. And actually, we just did a Geminids event with them in December. And we're going to be doing a Lyrids event with them, hopefully in April.
Is that McDonald College, St. Anne de Bellevue?
Yep, that's so part of our campus is McDonald College and part of our campus is John Abbott College.
Okay, great.
So
Great.
When you're in the neighborhood, come on by.
Absolutely. And Glenn, you also write a column, an astronomical column. Is that correct as well?
Yeah, I'm a syndicated columnist here in Atlantic Canada. I've been writing, 25 years or so. I write a weekly column. So 52 columns a year. On various astronomy topics, and they're published in the maritime newspapers, and they're online and that. And I do interviews with radio hosts and different shows across Canada. I've done them in Montreal. I've done them in BC and whatever. Mm-hmm. So,
and if you get a chance to visit the Maritimes, the skies there are incredible.
It's really you should. I have I'm an avid salmon fly fisherman, and I have a place up in Cape Breton, Nova Scotia, up Margaree Forks, and the skies up there are just to die for. There's no light pollution. It's like you could reach up and grab the sky. That's where I take my 12-inch Meade SCT. And boy, do I ever get into a bunch of deep sky objects up there. So, yeah, you're talking about, seeing the night sky outside of the urban area. Well, you need to go to Cape Breton, to the top of one of the high hills there, if you want to see a clear sky. I suppose it's comparable to Arizona or Mauna Loa or whatever, but it's just magnificent. So, yeah.
Wonderful. Wonderful.
Yeah, so I write those articles every week, and they're fairly good response. I get a lot. I have a couple of hundred people I send the articles to directly, people who have written me and asked me different questions, or queried about something that I've written and whatever. So it's a bit challenging at times, because I sometimes forget if I've written about that over the last 25 years. So
right.
Yeah. But I always try and put a new twist on it, and I try and keep it at a fairly non-technical level. I mean, you get into a little bit of it. Like this week's article was about Kepler's first law of planetary motion, and the one that I'm sending for next week is on his second law. It's a little technical, a little mathematical and that, so some people won't get it, but I try diversifying it. So
sure. And what do you find your greatest satisfaction to write? I mean, what aspect of astronomy really fascinates you?
Actually, my my heart of hearts object are comets. I'm doing some research. I think I may have mentioned this in one of our last episodes, that I'm doing a book, trying to compile a book on great comets through history. So what I'm looking at is for literary references to comets. Victor Hugo's, is it Tale of Two Cities? Or no, Notre Dame. His book on Notre Dame. In his introduction, he talks about a cometary fragment, a fireball hitting Notre Dame, or the Palais de Justice in Paris in March of 1618, I believe. So I'm trying to, and it actually, I guess, burned down the palace, but there was a riot going on at the same time. So I'm trying to qualify whether that is just a literary license, or in fact that it happened.
That it actually
in history.
happened.
So
Wow.
I like that kind of historical research and what. But comets, if I may, I just, following Mr. Levy about his poetry and stuff. I write poetry myself, and I have just a very short little poem here on Comet Hyakutake in March of '96. If I may,
Okay.
I'll just read it.
Please.
In gown of ice and stardust fine, woven from cloth of heaven's design, this anxious bride in hurried flight crosses the dark ocean of the night. On she rushes, drawn fast by fate, to a fiery marriage with her mate, innocent that his wild embrace will consume the passion of her race.
Wow, that's nice. That's nice. That's the first time I've heard that. Beautiful, beautiful.
Thank you.
Well, Glenn, thank you for coming onto the program. Is there anything that you'd like to add before we transition here?
Yeah, well, just to thank you very much. It's a pleasure and an honor to be present with you folks. I mean, I recognize some of the names here, and it's a great honor to see them actually face to face. I was looking through some of my old astronomy articles, magazines, and I found one from, let's see, when it would have been May, June 2010. That David Levy wrote about trials of my Meade 14-inch, where he crushed it with his the roof of his
yes, he did.
Yeah, and then there was another article, Astral Business: A Way of Inspiring Evening Stars. So
Yes.
him and Mr. Eicher, I don't know how to pronounce your last name.
Eicher.
It's
Eicher.
Eicher,
Yeah,
German.
okay, I've
Yep.
enjoyed both their writings over the years in the Astronomy magazine. So it's a great pleasure and an honor. I mean, these are the people I've kind of looked up to over the past 30, 40 years or whatever. So it's a real pleasure to finally say, I know that person.
That
I mean,
guy.
in one sense, I do. So,
Right. Right.
so, again, thanks for the invite, and I look forward to future sessions.
Yeah, we look forward to having you back on. You're welcome, of course, anytime that we do Global Star Party. So Glenn, thanks so much. And now I definitely have the face with the name, so I'll make sure that I make an appropriate announcement poster for you for the next time that you're on. But
Okay.
we have coming up on, is it February 15th? Is Galileo's birthday celebration, 158th anniversary on Tuesday night, which will be a Global Star Party. So that will be one of the Global Star Parties we'll do. So it's, if you're looking to be on one of the, what I would consider to be one of the really special celebrations, that's coming up soon. And I think February 4th is Clyde Tomba's birthday. Is that right? Silence. I'm going to say it's right. So
Yeah, we'll have to look it up for you, Scott.
I think it is February.
You are
4th.
right. It's February
If
4th.
Dave Levy isn't here, because he'll know it off the top of his head.
I was confused because his birthday is January 17th, but yes, no, he passed away on January 17th, but his birthday is February 4th.
February 4th.
Okay, there we go.
All right. So yeah, because we did like a whole global star party because February 4th, I think last year was on a Tuesday. So
Yeah, it was. Yeah.
yeah. So anyways.
But celebrating Galileo is going to be a lot of fun in 2 weeks.
That's right. Yeah, that's right. So, okay. All right. So coming up next is the vast reaches. Jason Guenzel. Jason has been on many global star parties, and we're always, blown away by the incredible imaging that he does. He is definitely one of the astronomers, one of the astrophotographers out there that squeezes out every last ounce, every drop that he can get out of a piece of equipment. So that is a hallmark of an astronomer with lots of expertise and skill. And so we're very pleased to have Jason on. Jason?
Thanks, Scott. I'm glad you're feeling better. Thanks for having me on again.
Thank you. Let's see.
Yes.
You've got two.
I'm on here twice because I share from a different computer.
Okay. All right.
Than the
So
one
there we
with
go.
the camera. So
I got
sorry
you.
about that.
No problem.
But,
okay.
I've got two main things I wanted to share, kind of separate topics, but we can go into the first one, which is the James Webb Space Telescope, and we've talked about that a number of times already on the program here. But it's a popular topic right now because it's a marvel of our technological engineering floating out there in space. And after it launched on Christmas Eve on December 24th, took a long journey out to the Lagrange 2 point, which is a gravitational equilibrium spot beyond the Earth, where it's in a stable orbit, far away from our planet and any of the heat or light pollution associated with it. And so it's got a nice view out into the cosmos. Well, that long journey, it took it basically on a grand tour of the night sky. And I thought, hey, wouldn't it be cool if I could take a picture of it, passing by some recognizable night sky objects. So I set about doing that, and it was a little more complicated than I had originally anticipated, but I'll walk you through the process here. Let me try to share my screen. Let me know if you can see it.
Yes, we can.
Okay. So starting off here, this is the JWST site that's published by NASA, where you can get updates on its progress and basically what it's been doing. One of the interesting things here is this tab this button called Where is Webb, and if you click on that, it shows its after you get through the pop-ups, it shows its trajectory from launch, and if you step out here, these are numbered in days as far as the significant milestones it went through as it moved out towards this L2 point. So you can see about 30 days after launch in late January, it got to the L2 point, and it was fully deployed. So now it's on to its commissioning. But my situation here in Michigan is a severe lack of clear skies. So I only had limited time to try this. And so on the night of January 10th, it was clear out. And I set about locating it and photographing it. So I opened up some planetarium software and saw that it was floating past the Rosette Nebula, which is a fairly common night sky object to observe or photograph in the winter sky. And so I wanted to get that shot, and what that required was a wide field telescope. And I'll show you what I used here. Let's see if I can open this. Photos. You see this?
Yes.
All right, so this is the telescope I set up to try to photograph the James Webb. And it's a wide field telescope. This is the TPO ultra wide, which is 180 millimeter focal length.
Wow. Okay.
40 millimeter aperture. So it's a very wide field telescope. It's essentially the size of a camera lens. I mean, you can see it here.
Mhm.
I mean, astrophotographers probably have a sense of scale from a ZWO camera on the back, but for anybody else, the front lens of this telescope is 40 millimeters, so just under 2 inches. And I'm shooting this with a monochrome camera and filter wheels. So I was trying to get it with as much signal as possible. So that's why I used a monochrome camera with clear filters. And so I'll hop over to my image through this telescope. So I think most night sky observers will recognize this as the Rosette Nebula, but a very wide field view of it. It's not that common that you see it in this wide field view, but
Yeah, it's really cool.
zooming in, we can begin to see the James Webb Space Telescope. Now, what I did is shot 40 millimeters, 40 minutes of exposures, 2-minute exposures, 20 of them, and stacked them up. And as we zoom in here, you can begin to see this streak, which is
Oh,
the
wow.
James Webb
There it is.
Space Telescope. So that's our $10 billion as we launched out into space.
Yes.
But yeah, so a challenging project, but I thought it was an interesting juxtaposition to see this telescope floating out there amongst some massive deep sky
Yeah,
objects.
And the
Literally,
perspective, it adds some perspective too, because you're seeing, obviously immense region of space, and standing next to Jay West, you're a little dwarfed by this amazing instrument, but there it is. It's just a tiny line out in space. So
yeah,
that's
so I've
very
got
cool.
this other crop that kind of, points it out. And then if we look up in the corner here, I've got the zoom in of that. So this is what's called a maximum stack, where you take all your image in the lightest pixels. Once you stack them, it becomes a streak. So that's 45 minutes of motion of the telescope through space. At the time I shot this, it was 1 million kilometers away on January 10th. It had recently fully deployed its sun shield. So it might seem counterintuitive how something 1 million kilometers away could be visible to a small telescope like the one I use. But that sun shield is essentially a tennis court size piece of mylar with its face pointing back to us. So the sunlight bounces off that sun shield and reflects right back to Earth. So it's almost like a beacon out there shining. And so one other view of this I did was to present this in video form. So these are now the raw captures. You can see the telescope here. You can see my mouse moving through space over the course of 45 minutes. And then I fade out using the background of that other image, which is a total of 4 hours of exposure to present the background scene. So zooming out just gives you that sense of scale.
Yeah, sure does.
I don't know if the video is playing smoothly at all. I'm guessing over Zoom, it's probably not too smooth, but
it's a little.
It's smooth enough. We can see the movement. It's really cool to watch.
That's right. That's really cool.
All right, so that's the James Webb Telescope.
That's the other thing I really love about Jason's images too. He gets creative in the way that he'll go about trying to capture something. He's trying to show us aspects of the universe from his backyard that I think a lot of people wouldn't have. Maybe there's some other amateur astronomers who tried to capture this. I know of none. So except for one, and that's you, Jason.
Well, yeah, I mean, I've seen other amateur. It's actually still visible out at its parking orbit, which is what 1.5 million kilometers away, so 50 or 60% further than when I captured it. And I've seen other images, but yeah, like you said, Scott, they're zoomed in and it points to a dot, and there's a James Webb Space Telescope.
Yeah.
But I like to try to give the perspective here of what this looks like out in space against the backdrop of some other deep sky objects that are somewhat recognizable.
So cool.
All right, so that's the James Webb Space Telescope. I pulled up the website here. This is a good resource for anyone that's curious. All kinds of specs about the telescope, and you can click in here and get some they have really nice multimedia images during the construction. Well, here you go. There's a shot of where is it? I was trying to show the sun shield here. I know there was one with everybody. Yeah, there you go. That gives a sense of scale on the sun shield.
Yes.
So essentially, when in my image, that's what I'm seeing is the reflectivity of that sun shield back towards Earth.
Incredible. At almost 1 million miles away.
All right, so keeping on with the theme of the Star Party Forged in Stars, I've got some solar images. Those that have followed me know that I like to shoot the sun, and presents some challenges during the winter time because the filter I use is sensitive to ambient temperature. It uses a heating element internally to basically put the filter on the hydrogen wavelength. And when the temperature drops extremely low, which it has been recently, the filter kind of drifts off band and doesn't work properly. So been kind of dialing that in and working on some changes. But I just want to show the team here that real-time views of the sun are absolutely at your fingertips whenever you want to see it. This is one resource through the NSO, and this is the GON Hydrogen Alpha solar network. So it's a worldwide network of telescopes that view the sun in hydrogen alpha, and these are all updated real time. You can see, depending on where it is in the globe, you'll get an update on how long it's been since the image was updated. And if you click on these movie tabs, you can play a movie of the sun rotating, and these are continuously updated. So I usually look at this as a resource to decide if I want to go out and shoot the sun during the day. And then there's also spaceweather.com, which is a great resource for solar activity and space weather. Basically gives you tips on incoming aurora, etc. All right, so now we'll look at the solar shots I have. Just to refresh the group here, this is the solar telescope I use, looking down towards the sun, but I've got a ASI 174 monochrome camera, which is a dedicated astronomy camera, which shoots at a very high frame rate. And that shoots in monochrome, which is useful for solar imaging. So that's what I use for the camera. In front of that, there's a Daystar Quark solar filter. And then this is the AR 152 telescope, the Explore Scientific, all riding on a Skywatcher EQ6R mount. But it gives a view of how low the sun is from my location during the winter. So during the winter, you struggle with not only temperatures, but also the altitude of the sun. From my location in Michigan, it never gets above 30 degrees. I'm shooting through a lot of atmosphere, and the stability of that atmosphere has a lot to do with the final quality of the image.
I don't know if
Here's
you
the-
intended to, Jason, but it looks like you got a sundog in that picture.
Yeah, maybe a little bit. Yeah,
There
over
it
here,
is to the left.
Yeah.
A little bit of sundog.
Oh,
Yeah,
right.
just a-
That's right.
Yeah, those are formed by ice crystals up in the upper atmosphere, probably in these cirrus clouds here. They appear, typically in the winter due to ice crystals up there. There's another view of that filter, and like I said, in the cold temperatures, when it gets down to like below freezing, or I think on the night or the day I was trying to image, it was maybe down to 10 or 15 degrees Fahrenheit, which is pretty cold. I started running into problems where the filter would go off band and I wouldn't get any detail. So I invented a new thing. It's called the solar sock. I cut up an old sock to insulate the outside of the filter, and I put a dew heater band inside there to warm up the barrel of the filter and to try to keep it on band.
Right.
This was shot yesterday.
I'm sure you're paying special attention to that solar sock, Scott. See,
I am.
one
I
you
am.
can
I'm coming out
make.
with solar socks tomorrow.
Yeah.
Looking forward to it.
Patent pending. That's right.
All right, carry on.
But by all accounts, it worked. So I'm back to imaging the sun after
look
a
at
hiatus. The detail had fallen off significantly with the cold temperatures, but using that sock and insulating and heating the outside of the filter, I can get the details back. So this is a view of the chromosphere of the sun from yesterday. And this is an active region, which is just rounded into visibility. And this is a sunspot. And so this is the active region here, and there's a prominence off the limb of the sun.
Beautiful.
And next
Adrian,
image.
you didn't happen to catch or to get a picture of all those filaments they've just discovered in the corona? It's been in the news just lately.
There was a coronal mass ejection a few days ago. Is that what you're referring to?
Well, not necessarily that. They were all these newly discovered kind of filaments that seem to be falling back onto the sun from the solar flares.
No, I don't. I mean, not in this series of images. There is an interesting phenomenon, which I'm not sure if you're referring to this, but it's called coronal rain. That's where a prominence, actually the globules of hydrogen plasma that exist out in a prominence, which is hanging out in the sun, those will actually rain back to the surface of the sun. And I've caught that phenomenon before in a real-time, time-lapse movie of this activity.
Well, these
But no,
seem
I
to
mean-
be something that that was new or something they hadn't seen before, and they were quite, inquisitive about it.
Okay.
I
Yeah,
can't
I mean-
quite recall it all, but I'll see if I can find the article.
Okay. Yeah, I mean, I'd
Yeah,
be curious.
Glenn.
I don't think that I've caught anything, like a new discovery here. I mean, what I'm looking at here is typical of what I can capture on the
Yeah,
surface of the sun.
Yeah. So,
this was
Glenn, do
just
you-
a few days ago. Yeah.
do you know if that came from from our solar probe or just a different observation?
I think from the solar probe.
Okay.
It was,
So it
they
might
had
be-
quite a bit. Yeah, it was just they were kind of like dark filaments that seemed to be dropping back down to the surface, and they were
Okay, yeah, curious to know if
something
it's-
new. So
Yeah, curious to know if it's due to this vantage point of the solar probe. Don't know if that's anything we'd be able to capture, even with
Yeah.
this level of detail that Jason's got. But yeah, it
Yeah,
is.
I'm not-
That does spark an interesting challenge.
I'd have to look into it, but yeah, one
I'll
of the
look
things.
into it further and send the info on.
Okay.
Yeah.
And one of the things I like about solar imaging is, you can put a little bit of artistic flair in to the images. these images are captured as monochrome, so they're just black and white. So all the colorization is done after the fact, and there's different techniques you can use to colorize. Generally, I like to colorize in the traditional, the sun is yellow-orange, just because that's the way we typically perceive it, although that's arguably not the true color of the sun. It gives a nice visual contrast and a little bit of an artistic flair to the image. So this image is shot with an inverted look. This image here is shot yesterday also with a slightly different processing technique where it's not inverted. This is a natural representation of how the chromosphere appears, where it's a darker structure over top of the lighter photosphere of the sun. And so these brighter regions are the active regions, and then the darker areas are the sunspots. This is just a little bit of a different way to look at it, but again, this is an active region that was shot yesterday.
Super.
And if you look on spaceweather.com, it's this group here. 2936 is the number. All right, so one last thing. Where did it go? Is I've got the original view that I shared as a time-lapse movie. Now, I have not really finished editing this, but it'll give you an idea of what it looks like in motion.
Yeah.
This is a pretty low contrast view. I haven't finished trying to boost the contrast and the details yet, but it gives you a sense of how the chromosphere moves around over time. And I forget the actual span of time for these captures. I can look real quick on the other screen
You
here.
can see some rotation of the sun.
Yeah, so it's stabilized on the sunspot, which gives a little bit of a strange perspective, because actually that sunspot is rotating. And so you can see the movement in the limb of the sun because I've stabilized on the sunspot. So yeah, actually this sunspot's rotating into view. And looking at the timestamps here, I've got 1749. So this is over the course of 1 hour, 1 hour and 6 minutes.
Amazing.
All right, well, that's what I have to share for you folks.
All right, Jason, thank you so much, man.
Yeah, thanks
You.
for having me, Scott, and I
Yeah,
hope you enjoyed
as
it.
always, it's a pleasure. So we are going to take a 10-minute break. We have more speakers coming up, including I think our next speaker will be Navin, Senthil, Kumar. He's a young astronomer. I think still, Navin, are you still in elementary school, or are you heading off to junior high at this time?
I'm already in middle school.
Middle school. Okay. All right.
Here they call it not junior high.
All right. So we will take a 10-minute break and then we'll be back. So go get yourself a cup of coffee and we'll see you back in 10.
I will definitely indulge in that cup of coffee. Great presentation, and I like the use of the images, Karim, because you saw what you could get when the skies are dark enough. And Glenn, I know you've seen very dark skies. I've had the ability to travel to various Bortle zones, going up to Bortle 1, and each time, the first time I see a site, I go, oh, this is as dark as it gets. And then I go to the next site that's darker, and I go, that's even darker than the darkest it gets. Then I go to Bortle 2, and the only difference I can perceive with my own eyes is how well detailed the Milky Way becomes. to where all the Bortle zones up the Bortle 2, the Milky Way might have some structure. I may be able to see some dust lanes, but everything's kind of in a black and whitish sort of look. It begins to gain what appears to be color right around Bortle 2. And then Bortle 1, to me, it's as bright as the full moon. And it shows up before the sun sets. The Milky Way just appears in the sky. So it's just been a pleasure to see that. It's hard to capture it in images, and I've actually tried to do so. All that happens is you end up with more detail with the same amount of exposure time on the Milky Way. When you shoot at it in different zones, you end up with a deeper amount of data that you can pick up just because it's the light coming from it. The other thing with the Bortle 1 zones from the Milky Way, the light is so bright that if there's clouds, you can see it shining behind the clouds like the full moon does. It doesn't do that in any other locale. And the brightness of the other areas of the Milky Way, we're talking the galactic core, the brightness of the other areas in the Milky Way is very evident too. And in the winter, that can be the only thing to shoot at.
Our Montreal Bortle scale, 9 wasn't good enough. It's, you've got to count 9 full moons as our Bortle scale. That's kind of the skies we're looking at.
Yeah. And I know Bortle scale, I've heard the complaints of Bortle scale kind of being, relative. A Bortle 1 zone can look more like a Bortle 2 zone. To me, it just comes down to visibility of the Milky Way and how.
This is one of the things I like about the globe at night, right? Because even though they do put numerical magnitudes, it's not the Bortle zone, but they do it with these star maps where you actually have magnitude guides and you go out and say, all right, I see about this many stars in this constellation that corresponds to the 3.5, or that corresponds to somewhere between 3 and 4. And that's really nice because it gives them something tangible to try to measure it rather than walking around with a photometer of some type.
Or with you've got that scale where if you get to 21.9 or 22, then you're talking not only dark, but I think you're talking transparent as well.
I'm curious, Glenn, out in the Maritimes, I mean, I know Chris Kerwin does his Astronomy by the Bay with Paul and Mike and stuff in New Brunswick, but over in Nova Scotia, do you guys have a lot of outreach events that you do? Are you really active in the local club? What are things like down there? Well, you're muted at the moment.
Still muted, Glenn.
Yeah, sorry, Glenn, you're still muted. It's all right. We'll chat offline otherwise.
Yep, I'll be back. I think we got a few more minutes in the break. So
yeah, time to grab some coffee.
Yes.
Not for you, Navin. You're too young for coffee yet, I think.
Yeah. Tea for you, Navin. Non-caffeinated tea.
I don't really drink tea that often, but I do drink milk.
That'll work too.
Hot chocolate?
Yeah, preferably. I drink that every morning. I love it.
Navin, are you interested in taking part in that alien drawing workshop on the 13th?
I don't really like drawing.
No worries. But if you're interested in giving it a try, then that one's open, okay?
All right, sure.
Hey, Nicolas.
Hello, how are you? Hi, Karim.
Sorry, I got booted out here, had to get back in. Who was asking me a question?
Oh, I was just
Oh,
asking
okay.
about outreach and events over there in Nova Scotia.
Well, I'm only like a satellite member of the Halifax Astronomy Club. I used to live in Halifax and was an active member when I was there, but I'm on PEI now. So we used to have we used to have an astronomy club here, but we lost our place at the university when Professor Wanacott who was the astronomy instructor at UPI. When he died, we lost our access to free lodging at the university, and the only way we could get a room was to pay $100 for every time we met. So that kind of we didn't have a large membership, so that kind of put a quash on our monthly meetings, and subsequently our club eventually dried up, and there's only 2 or 3 of us who get together now.
Are the others still in the area?
There's a couple of people still in the area who, we get together and go out and do a bit of observing or take pictures and whatever, but we've lost the balance. A lot of our members were older members. A good number of them have died, unfortunately. So, and some of us, as you can see, are getting quite gray and long in the tooth. I'm 75 myself, so yeah, we're losing our membership. We've tried to reactivate the club, but without a place to meet, we've only been able to hold periodic outdoor gatherings.
We'll touch base by email because I do have a contact at UPEI, and I'll reach out and see if they're willing to step in and maybe give you a hand to get something set up again.
Yeah, I'd appreciate it because we'd love to get something going again. And I mean, I miss it terribly, and I know the other members do. We've also tried to get into the schools, but because of COVID the last couple of years, we've kind of been pushed to the back burner. But we were hoping to get a kids program going where we could go in and perhaps once a week or once a month or bi-monthly. Have a half-hour talk with children, grade school from say.
Do you know Chris Kerwin from New Brunswick?
Sorry?
Do you know Chris Kerwin from New Brunswick?
No, I can't say I do.
I'll connect you to him because he's been doing Zooms into the classrooms, and he's always looking for more volunteers to help out and to do some of these Zooms, because it's classrooms throughout the Maritimes. He doesn't just stick with New Brunswick and to St. John. So I can chat with him and connect you with him by email. And that way, I mean, this is the thing, is when you're in such a small part of the country like PEI, it's very hard to feel connected to everyone else. But right now, there's actually all of this amazing stuff online. So let's get your group back up and running and connected with people.
Sure, that would be much appreciated because it's very important to me, and I love passing it on to younger people. That I hold public talks in the parks and that here periodically. I've got my grandchildren all into it and everything. So it's dear to my heart, and and we've let's follow up on that.
And I think I'm going to be doing a Zoom talk for Halifax in a couple of months. So I will be talking to Judy again. And so let's see what we can do.
All right. Sounds good. Thank you.
Awesome. My pleasure.
Okay, everyone, we're back. Hopefully you had a nice few minutes there to get ready for our next series of speakers. I always love to have young astronomers on, and young Navin has given us now several presentations. It's when you listen to what he has to describe, you can tell how passionate he is about space, astronomy, and the universe. And I'm very certain that he'll go on to do some great things in his life. So, Navin, I'm going to turn the stage over to you. Thanks for coming back on to Global Star Party.
All right, thank you for having me. So today, I'm going to talk about how stars are born and made. So let me just share my screen.
Okay.
All right, so I got the presentation.
Navin, do you give presentations like this in school?
I do not.
You do not. Okay. I'm glad you can do them here.
Sorry, 1 second. All right, let's start here.
Sure.
How stars are born by me, Navin Senthil Kumar. How are stars born? Stars are born in nebulae by forging pieces of dust and gas, and they expand to make stars. A familiar example of such as a dust cloud is the Orion Nebula, of course. This is an image of the Orion Nebula. This is also another image in high contrast of the Orion Nebula. All right, let's go to how are stars born next. Stars are mostly made of hydrogen and plasma. So the first thing in the birth of a star is called a protostar. A protostar takes about 100,000 years to make and complete. It doesn't have any internal temperature and pressure to begin its fusion at the center. And if you see a protostar here, if you want to see it being made, it's kind of like a galaxy. For example, the star's in the center, which is right here. And the surrounding is all orange, dust and gas forging together to make this young star. And sometimes light comes in to also help produce the star, and also plasma. All right. Now the process of star formation. The first step. A, the stars come in a dark cloud, like a nebula, for example. Then the stars are formed in dark clumps. Step number 2, the stars are in the prestellar core, which is right here. And then number 3 is the star turns into a protostar, and it takes 100,000 years. And step number 4 is the Tari star. It takes up to 1 million years to make a Tari star. Step number 5, a pre-main sequence star. It takes up to 10 million years to make a pre-sequence star. Step number 6, for a main sequence star, it takes more than 10 million years, and the size is about 50 astronomical units. So this is the 6 steps of creating a star. A solar system typically lives around 10 billion years. Our sun is currently in the middle of its life process. We currently have 5 billion more years to go. And after a few million years, the process also halts. Now the star is born. And also the star has now has an internal temperature, and it can start producing on its own. Oh. All right, that's all for my star birth presentation. Now let's go to my astro photos.
Okay, I love this.
So this is my first astro photo. It's a lunar eclipse through my telescope in my backyard. Yeah.
You nailed it. It's great.
Very well done.
Now let's go to the next one. This is a picture of Jupiter through my iPhone 12 Pro Max in my backyard.
Mm-hmm.
Jupiter's right here and Saturn's about right there. And they're kind of blocked in the clouds. And you can see the light pollution from over here. and now you see a seagull. We went to the Chesapeake Bay over for Christmas, and I also shot this through my phone. So we were in a scenic overlook on this wildlife refuge called Fisherman's Island. It's off the coast of Virginia in the south, facing the Atlantic and the Chesapeake Bay. Now this is another image. It's on the same overlook. You can see the beach kind of over here, and then it's like with the sunset, and you see the waves coming in from the bay. Oh, sorry. Oh yeah, it's the same. And then you also see the bridge over there, and you see like a seagull floating and flying.
Yes.
And you see, and yeah, that's all. Thank you. Any questions? That's all.
Let's see. Beatrice Hines, who's a great astrophotographer as well, said great image of a seagull too. And Jeff Weiss says great job, and they're happy to see you on the program. Navin, thank you. Thank you so much
for having me, and thank you, Sport Pacific.
Yeah, that's awesome. Thank you so much.
I'll turn the stage over.
Excuse me? Oh, okay. Do you have anything more you'd like to say before we transition here?
Nope. Do you?
Nope. Okay. All right. That's great. All right. So up next, we've got Adrian Bradley. Adrian has graced many global star parties now with his beautiful nightscape photography. He is, and he helps us explore, various aspects of the Milky Way, what can be seen with the naked eye, but also and he gives lots of tips as an expert photographer, and how to handle a digital SLR in these low light regions and what you can capture at night. So Adrian, thanks for coming back on, and looking forward to seeing what you got.
Well, thanks for having me, Scott.
Yeah,
well, thanks for having me. And awesome. So as I jumped on early and I heard, David Levy was talking about Van Gogh and how the night sky inspired him to want to draw it, want to paint it. And for me, I understand that feeling, because the desire to capture the night sky comes to mind whenever, and just being out under it, even if my images aren't as good that night, or, things don't go as well, or it's blustery or cold, I still enjoy looking up. In our region, we're not going to see too many stars because of the snowstorm coming into our area in Michigan. So last night I got a chance to see the starlight for what could be the last time in a little while. And I tend to like to be out there to capture it before the clouds cover it. So what I'll do is I'll share with my presentation layer. We'll share this screen, and I'll take our chat and move it here. So these are the images. Whenever I pull and copy a few images, as I'm listening to the star party, I may be inspired to share some of the other images, some older images, if I feel that they're a part of the conversation, and newer images that I take. So we'll start with the Lunar New Year. And this is one of the images that I have not been able to replicate. I don't know if it was the circumstance of the moon rising and the cloud cover being perfect. This is one of my favorite spots to image, but in a single shot, I managed to get the full moon with some detail, clouds illuminating it, or it wasn't full. This was maybe a couple days past full. And you have the reflection on the lake here, Lake Huron. I haven't been able to reproduce this shot, and even though I have settings and time of day and everything, just one of the shots that after some processing, this is how it turned out. And so this is my nod for the Lunar New Year. And I'm actually hoping to print something for that. So that's my nod to the Lunar New Year. I'm also hoping to write a book about this place. This is Point O'Bark Lighthouse Park, one of the few places in Michigan. We were talking about places where the sky gets dark, and this is the thumb of Michigan. And I've captured a number of images over the last couple of years at night, some during the day, but mostly at night, of this place. And I'm hoping to put them together and in a sort of illustrated book, just describing the images, what I saw. This night is going to feature very prominent. The 2021, the spring equinox, and that the aurora was visible in the distance, and it was very active but visible. And the thumb of Michigan is maybe 42 north latitude, so even as far down as the thumb of Michigan, you could still see the aurora in the distance.
I like the foreground in that image too. You know, the way it leads your eye into the lighthouse, and then that just golden color is beautiful.
Yeah, I was able to capture a few colors. Now, if you turned around, this is the way the Milky Way looked when it was rising around the same time. So there were plenty of things. This is like turning around from that on the other side. There's the red light that's casting that glow on this part. So there's a platform here where I was standing. I come up here and I turn around, and this is the view you see after you process it with the camera, the Milky Way rising out of the lake. So it's a very beautiful place to image. We talk about seeing all of these stars and, you know, things being forged from stars. Nothing's like looking up and seeing millions of them. Here's the image that Karim shared with you. If you look at this image, I mean, this is all you see. Just look at the little stars that are in this image, I mean, let alone the large ones. I mean, it looks vast. And looking up and seeing that naked eye is quite an experience. Yeah. This is a familiar image for those of you who have read Skies Up magazine. This is the same, essentially a similar region. Sirius hasn't risen yet. This is what it looks like when you take it with a camera that can capture H-alpha data, and you image enough to capture the dust lanes. This is a not as often imaged part of the Milky Way. When you think Milky Way image, most folks go for the core, this stuff, because it's the brightest thing there. And in a Bortle 1 site, it's so bright that clouds try to cover it. This is what you end up getting. That's there's M5. There's the Sagittarius star cloud peeking through. Hey, here's I think M16 and M17, or M17 and M17, I forget which one. They're peeking through the clouds, which are dark underneath. You know, once you get away from light pollution, the sky changes. So, you know, you do what you can to get away from light pollution. Sometimes we can't, but we can go to some places that are dark enough. They cast a little bit more of a bluish hue in the sky. This place is northern Michigan. It's still lower Michigan, but it's a northern part of it. And some of the nebulosity you saw that I had captured shows up. This was taken a week ago Friday. I braved some colder temps to get on a bridge overlooking this river. I had wanted to take this shot for maybe a year. I had planned on doing that. What I didn't plan on was catching this green glow when I turned the other way. This is the other way on that bridge, sort of facing north. You've got North Star right here, and my processing appears to have mangled the Big Dipper a little bit. Sometimes with a wide angle lens, sometimes we lose some of the edge. So it's definitely something to work on. But here's that Cygnus region. To the naked eye, it just to let you know, to kind of level set what you see. We don't see quite as dramatic. So this is naked eye view. You're looking up and you're seeing the skies. You see a little more contrast. If I darken this a bit, it's really close. There was some auroral activity, so faint. And that's as accurate as it goes. Now you do a little bit of processing, and then more of the hydrogen alpha, you pull some of that out, and this is what you end up with. I believe I actually, for whatever reason, thought this might have been sky glow, even though I was looking north. And when I looked at the numbers, as it turns out, I'm saying, oh, that very well should have been, could have been Aurora. This, I don't think it's a comet. I think there's something else going on here. I don't think I captured the remnants of Comet Leonard at this point, but this was interesting to me. I wasn't sure what artifact that was. That is a meteor. Like I said, it can be easy to catch meteors when you do night sky imaging. And let's see. Then when it comes to what does the internet like when you do night sky photography, colors tend to draw in attention. So getting colors like this comes in partly from what light is available. Moonlight was coming up to the left off camera, creating that, this light here.
Yeah,
and in processing, you still have a little bit, because I use the H alpha modified camera to get some of this, but this part of the El Sable River was melted, or mostly melted. This may be a sheet device. I wouldn't try to jump in it because you'll fall through. But this part of the El Sable River behind me was a light coming from a dam that was, controlling the flow of water behind me, off on a bridge late enough at night that no other cars are passing. Colors brings everyone else in that isn't looking for a specific sort of scientific view of, what's going on. I do like the objects in here to be accurate. And that's one of the reasons, like last night's haul, I went out and took some pictures, and here you have just a star field. This may not appeal to a lot of people, but it appeals to me because every star here, it's pretty accurate. Now, when you process, you lose a little bit of detail that you may not realize, such as this glow right here is M101.
Oh.
And sure enough, there's a glow further. It's hard to see in this image where M51 is. This is Alcade. And as you know, a right angle off of Alcade, and the M50, the light from M51 appears. I do believe it's this area right here where it's the light of M51. So there are treasures to see, even in simple night sky images that you take. You've got flares, but you've also got some detail here that is worth looking at. So not just a pretty picture. I like things to be as accurate as I can get it. And I also like to see what I can see, even if there's clouds. you sort
Yeah.
of see the starlight coming through clouds, and it produces an interesting picture. So, this little, I believe M46, M47, and I believe this might be M48 right here. So these objects are in the sky. When night photographers do night images, a lot of times some of this detail gets sacrificed for the sake of making a pretty picture. And I sometimes do it too. I think with any of the images here, this is a Bortle 2 Milky Way. When I first saw the Milky Way in a Bortle 2 sky, some of this coloration here, if I had it to do all over again, in fact, I have some raw images, so I will probably play around with it and see what I can do with some of the newer processing techniques I have. But for instance, this dark nebula, Barnard, it's a dark Barnard's Nebula. It shows up. Those things are important to me. I like things to be not just nice and pretty, but accurate. The coat hanger appears where it's supposed to appear. This is part of the summer triangle. There's, let's see, from Aquila the Eagle, Altair, and Tarazed. They show up. And if you pull back, I don't think we quite get Deneb. I think my image cuts off before you get to see the other pieces of this summer triangle here. But I like everything a little more. I like everything to not only be beautiful, but accurate, yeah. And then you think about it, all of these stars that we're seeing, most of them are super giant. And then you're also seeing nebulosity that the camera can pick up from however many millions of light years away. And we can study it or we can enjoy it. The aim of most nightscape photography is you have something here that's also beautiful and the two play off of each other. Sometimes I just shoot the night sky for what it is because I think it alone is beautiful. So there's always. So with that, I don't recall if I showed I showed this one. The winter side of the Milky Way deserves attention from night sky landscape photographers. And you can compare the Bortle 1 Cygnus region. This is a Bortle 1 Cygnus region, I believe, shot with a non-modified camera compared to what I would classify as a good Bortle 3 zone. Maybe a little sharp process, but this stuff is definitely there. There's Orion. Or not Orion, there's your Andromeda Galaxy. In some of my shots, M33 also appeared, so did NGC 752. So with that, as always, I like to end with a bird photo. Sometimes
wow.
Luck plays a part in some of the imaging that you do. You can plan as much as you want. It sometimes takes that extra lucky button press or that lucky chance exposure, much like one of the images I have here. And most of the time, you're going to catch a meteor if you keep trying, and you do long exposure photography. A meteor will somehow streak through your image. And I know I showed one earlier. I do believe it's this one. Yeah. Whatever this is, I have to make sure it's not just an artifact. I didn't happen to catch a comet. I don't think it is. We'll have to see what that is. But there's your meteor, and there's your plane. Oh, I forget if it's northbound or southbound. There's even a streak over here too. You catch a lot when you're dealing with the night sky.
Yeah.
There's always a lot going on in the night sky. So with that, I will turn it back over to you. If anyone has any questions, feel free to, on the chat or in the, watching live, feel free to send questions.
Yeah. You got lots of accolades as you normally do, Adrian, because your work is so inspirational. It makes it makes you sit back and just want to soak in the beauty of the night sky as you're seeing, as you're showing us through your lens. But those of you out there who are photographers, I think it also inspires you to try to go out there and get something like that yourself. So,
Adrian, I think we need to get you to like schematically show us a workflow at some point. I think we need to like.
I'll work on that.
We got to sit in your brain for a few minutes. We got to see how things.
Workshop is what we need.
Yeah,
with the schematic.
I'd be happy to do that. I'd be happy to do that. I'd be remiss if I didn't wish a happy birthday to Beatrice Hines, who's in our chat.
Yes.
I believe.
Yes.
Yeah, happy birthday,
Beatrice.
Beatrice.
Birthday.
Yep.
Yesterday, I believe. Yeah.
Yeah, I would be happy to do that. And it's been evolving over time. I've taken some, the classic astrophotography, things like using flats. I haven't incorporated them as much. A lot of it has to do with the aim of the image. Like the one where it was a darker blue sky and you had the river going through it and a lot of color. The aim of the image is create a beautiful image with some realistic elements in the sky. A lot of times it's marrying the two images. I want the sky to be realistic, and I want the foreground. The foreground may not be a grand thing, or like a lighthouse, or sometimes the lighthouse is there or something else is there, but I'm trying to show the beauty of the night sky. So
no, but you even do a great job.
Progress and work.
You do a great job framing your photos without using something like photo pills or something where you have to really be careful of exactly when you set up. You have this eye for getting an incredible foreground to frame what you're trying to show us in the background.
I appreciate it. And, coming from an astronomy background, it means I don't necessarily have to use photo pills. I could use Sky Safari, use the same tools that a visual observer would use. We're trying to look at certain things in the night sky. So as far as those Milky Way shots rising, 3 a.m. for those, you're looking and you're seeing, okay, the core is coming up at 3 a.m. Most of the time, for the photography side of it, some photographers will learn the astronomy part of it. They'll learn enough to be able to say, okay, if you want to frame the Milky Way core, you got to get up at this amount of time, and then they'll do the planning. The detail in the Milky Way, sometimes it can be made to be beautiful, but sometimes you'll have the rest of the sky just completely blown out, or the sky masked out by the processing. So you end up with a Bortle 3 or Bortle 4 zone. The Milky Way looks like it belongs in the Bortle 1 zone. And it's turned into a beautiful composite. I think there's a time and place for composite shots. They spark the imagination. And I like the angle that I come from is I appreciate the night sky for what it is. And so when I'm shooting at the night sky, I'm like Van Gogh. I'm simply trying to paint what I see, and instead of painting what I see, capturing what I see, and just transporting you to all of these places where I'm seeing it. Even if I'm not seeing the exact detail, I know it's there.
Are you telling us Don Henley's going to write a song to promote your book for you?
Maybe. I'll have to ask him. But first, I got to get to writing this book.
Harold has already pre-ordered a copy. So you're going to have to get...
Right now on Explore Scientific, you can pre-order Adrian Bradley's Nightscapes.
I'm going to get to work on that book then.
620-page book.
I want one idea.
I think we'll start with 50.
Yes,
okay. And we'll have a forward. All of you will be able to put a forward in it.
One of the bird touching the water in the portrait. It's fantastic.
There you go. Yep. And that one of many books of just chasing the night sky. The Southern Hemisphere one will happen. I have to convince myself to get down there, and maybe even soon. But
Okay.
again, thank you all for having me. I'm going to look through the comments. Thank you all for the excellent comments. It inspires me to keep going. I mean, it's the night sky inspires us all, which is why we're here. It's why we're glad you're well, Scott, and we're able to put this
thank
on
you.
for everyone that's across the globe. I stayed up late last night knowing I had to go into work in the morning because the night sky is going to be gone for a week or so thanks to the snowstorm coming in. So this was my way to address it. All right, Scott, I'll give it back to you. I'll be talking all night, so you better take it back.
Adrian, thank you so much for sharing again. All right, thanks. Up next, we have Nicolas Arias, also his nickname is Nico, or Nico the Hammer. I call it Hammer Time with Nico. So Nico, it's great to have you back on Global Star Party. Nico, what is the name of the city that you live in Argentina?
Good night, Scott. Well, I really missed this CSP. It was a long week.
Yeah,
Here,
it was long for me too, so.
Yes, and it's really nice to see you really okay and in a good mood.
Thank you.
Here, I live in a city. It's called Banfield. It's outside of Buenos Aires city, like maybe 15 kilometers of the Capital Federal in Buenos Aires. Okay, now hi to everyone. I hope you are all okay, and you are. I'm outside right now with my scope. I'm here with my daughter that she wants to say hi.
Hello.
Hello.
she was waiting like an hour because tonight I'm with both of my kids, and she was waiting.
Oh, that's great.
To say hi. Okay.
Nice.
Tonight I'd like to share something. Let me change this. Are you seeing my screen?
I can tell you're sharing your screen. It's not quite there yet.
Yeah.
There you go. Yes.
Okay. Well, tonight, as I had no much time, I take to my astropatio my scope, my 6-inch scope with my equatorial mount, so I can track what I want to show you. And as you can see, this is real now live, the Carina Nebula. This is a live view with 10 seconds of exposure. And the topic of tonight always drive me to think about the power of the stars and the explosions are and it always took me to think about Eta Carina, that is a star that blows my mind, and not just because it's a real giant star that one day will become an hypernova. Not all of that, but this particular star had exploded at least 2 times, expulsing some material. And here in the Carina Nebula, if we close up the image, we can really see the Homunculus Nebula, that is a little nebula, like a planetary nebula. And let me show you. You need to lower the exposure because the star is so bright that you cannot see it. Let me change some parameters to find this. Okay, this is the star. As you can see, it's really, really bright. If I take 1 second exposure, the star is really bright. But if
this
you
is live through your telescope right now.
Yes,
right?
yes, this is live now.
Wow.
And if you drop the exposure, let's try maybe 100 milliseconds, you can start seeing around the star the little nebula. That is the homunculus nebula. Let's do some zoom. Can you see it
Yes.
around the star?
Yes, you can. It's like a faint haze.
Yes,
Mhm.
and it's amazing that with the scope, with an eyepiece, if you use a big magnification like 200x, for example, you can see like years around the star. It's a beautiful nebula to watch. You can see really really shy behind the star, the brightest star. And a few nights ago, I took a picture of that with my Dobson, and let me find it so you can see how you see when you stack these images. And here we are. This is what you can make with
Oh, you
really
can
low
definitely see it
exposures
now. Yes.
and stacking a lot of images. This one was maybe 500 images stacked, and I have another one, this one, and you can see even the shape of the two lobules. I don't know how to say in English lobulus. It's like the two bubbles around the star and the pikes that there is a really nice picture of the Hubble telescope of this nebula. And this is one of my favorite objects to observe in the city, because when you are in a great sky, the Carina Nebula hides this. You see all the nebulosity, but not this little nebula that was discovered here in Argentina for Enrique Gaviola in the Bosque Alegre Observatory in Córdoba. But it's amazing because you have another this sky object hiding in a really big deep sky object like Carina Nebula. You can see we will back with 10-second exposure, and there is impossible that you see that little nebula because all the nebulosity around. Let's wait for the camera. There you are. There is the K-hole nebula in the center, and well, that's all for tonight. I was waiting to share this to show how
it's great.
in the big Carina Nebula you can find this hidden object that is really beautiful to observe with an eyepiece.
Yes. Next time I'm in the Southern Hemisphere, this is definitely something I want to observe. So
yes, and here here we have right now it's about 60 degrees in altitude. It's really high in the sky.
Right. Beautiful. Before you go, Nico, what telescope are you using tonight?
Tonight I am using a 6-inch Newtonian telescope. It's a Hocken in an equatorial mount, an EQ5 of a Skywatch.
EQ5. Okay, wonderful.
Yes.
Wonderful. Yeah, amazing what you can see with the 6-inch telescope. And
yes, it's a little one. Obviously, with my 10-inch Dobbs, it's amazing to observe this. But tonight I prefer to use the equatorial mount for the tracking, so you can I can show you both things: the nebula with exposure and then the homunculus nebula.
Great. Well, so I shared a link on Wikipedia about the homunculus nebula, and
Homunculus, yeah.
is a little difficult to pronounce. You said it was discovered in Argentina, is that right?
Yes, it was discovered here in Argentina for Enrique Gaviola in an observatory on the province of Córdoba. That is called Bosque Alegre Observatory. I don't remember now the year of the discovery. And the name, the homunculus, it brings from Latin that a little man, because I don't know, he observed and thinks about the little man.
Very cool, very cool. Thank you very much, Nico.
No, thank you, Scott.
Thank you, and enjoy your family time. Take care.
Okay.
Great presentation.
I think I will be there for minutes because the little one of my kids is asleep in the couch, and, and my daughter is watching television, so I will be here.
Yep, you're welcome to hang out with us. That's great. Thank you. Okay. All right. So we've gone from Argentina, and now we will go to Brazil to visit with Dr. Marcelo Souza. Marcelo is getting ready. He's starting to make preparations for his aeronautics and astronautics symposium that he conducts each year. This is the 14th one, I think, that is coming up in April. Is that right? Yes. So, I will turn this over to you, Marcelo. By the way, Marcelo is the editor of Skies Up magazine, and I will put in a link so that you can download your free copy of this Global Astronomy magazine.
Nice to meet all of you. Hi. I also had COVID last week, Scott, but it was mute for me also. Here in Brazil now, a lot of people are getting COVID now. And I would like today to talk about something that will be maybe the most important astronomy event here in Brazil. That is the eclipse, the lunar eclipse on May 16. This is not a picture of the lunar eclipse, but here, that is because I also, when I talk about eclipse, I like to show first this image that for me is fantastic image, that is a solar eclipse from the International Space Station. Cool. This is fantastic. But here, and this is part of the presentation that we do here, different sizes of the moon and the earth. Here is a picture that shows the moon and the earth as we see from space. It's a American spaceship that took this picture. And this is what we use as reference for us here when they talk about eclipse. And we are preparing material from now because the lunar eclipse here is very popular here, and we have a lot of people that want to participate. The biggest event that we organized here was the observation of lunar eclipse. We had more than 10,000 people that participate in our city. And this eclipse on May 16, it will be possible for us to see all the eclipse from the beginning until the end of the eclipse. I think that in all South America will be possible to see. It will be a big festival here, and part of the United States. I think that Florida and they will be possible to see all the eclipse. Here's what we use to show why we don't have all the time eclipses, because of the inclination of the earth, of the moon. When we compare with the eclipse, that is the orbit of the earth around the sun. But I will not talk about this because all of you know everything about this. This is, I'm going to show what is the reference we use for the eclipses here. And now I would like to show is an activity that we are planning to do this year, educational activity that we did 4 years ago, 5 years ago, 4 years ago in 2018. That was the last big eclipse that we saw here. And here we see the date. That's .com. That's a fantastic homepage. And here you see that for us it will be a fantastic time on May 16. All the South America, Central America, part of Mexico, United States and Canada will be fantastic. You can see all the eclipse, and we organize from now because many people will try to participate. Here's information from our city in campus here in Brazil. We see that for us here, the partial eclipse will begin in this time that I'm talking now. That will begin the eclipse for us here in Brazil. And we can see all the eclipse. The partial eclipse ends near 3 a.m. here in Brazil, here in our city. Then it will be fantastic for us that you have the opportunity to see all the eclipse. And this will be the first and most important event for us. We will have another eclipse, but this is the first one in 2022 for us. And the activity that we are going to organize is the same that they did in the past. That when you have a partial eclipse, here you can imagine the size of the shadow of the Earth. It's a shadow cone. This is part of the shadow cone, and we use this as a reference to do this activity. We ask the students to take pictures or make drawings of the partial eclipse, and then using only geometry, trigonometry, they can know the distance from the Earth to the Moon in the moment of the eclipse. This is what to ask the students to make the calculation, using only the similarity of triangles here to solve this. This is fantastic because it is what they did in the past.
That's cool.
And we can do this again. And now everybody has smartphones with cameras, with zoom. They can use a zoom of some of telescope that you use, or can draw what they see, and then we can use this as reference to determine. Then we compare this triangle with this small one. That here is the cone, the shadows cone that I have here, because many people don't know because that the shadow that you see over the Moon, the shadow of the Earth, is not the size of the Earth. Many people think that it's the same size, but it's not the same size of the Earth. We have a shadow cone. Then, with this information, we can calculate the distance from the Earth to the Moon in the moment that they took the picture. Here is an example that we did. And this is the material that we give to the students and to the teachers. They organize the activity during the event of the eclipse observation. Well, I have here approximately the distance that will be like this, 362,000 kilometers. That will be the distance that they depends of the time that they are going to make, but it's near this that they need to find. And we use this, that when you organize, we ask people to use a template to help them to measure with naked eye. Then we organize this template. Then they have here the reason of the size of the shadows, the shadow of the Earth, and the size of the Moon. Then they can use this as a reference to make the calculus, to know approximately the size of the shadow, and with this information, we give to them the size of the diameter of the Earth, the diameter of the Sun, and the distance from the Earth to the Sun. With the information, then can find the distance from Earth to the Moon in the moment of the eclipse. This is an example that is possible to organize activities that can motivate them and show that is mathematics. They need to study mathematics for everything. And in the past, they did everything. They measured distances between the Earth, between. They knew the stars that are nearest to us using only trigonometry. That is something I don't know if I'm saying correct. It's trigonometry. In
trigonometry.
English,
you said it exactly correctly.
Yes.
Yeah.
This is one of the most powerful tool that they had in the past to study the sky. Then doing this, they can also feel like in the past the people felt when they measured this, they solved the problem like this. This I ever showed this image because I didn't forget that it was the event to see the lunar eclipse, total lunar eclipse in 2018 here. They had 10,000 people on the bridge. They closed the bridge, and we had 10,000 people here.
10,000.
10,000.
Wow, that's huge.
During all the eclipse, we had 5 telescopes there, but we can't connect one with the other because we have a lot of people in between, and it wasn't possible to have any kind of contact. Remember, you can't see here because we took the pictures near the telescope, but if you take the pictures from the beginning of the bridge, you can't see the telescopes. You see only a lot of people there. That was something that unexpected because we asked to close one of the lines of the bridge. Then when I arrived there, we have policemen there. You have people selling hot dogs, beverages, drinks. A lot of people, and the bridge was full of people. Here you can see here. And it was transmitted live by TV, by the 2 TV channels here in our city. Because a lot of people were there, then they participate. All the newspaper. It was the biggest event that we organized. The first one that we organized in the public square downtown, we had 2,000 people before this eclipse, the other eclipse before. And when we did maybe because they knew about they will close the bridge, and then a lot of people would like to see what was happened, and then they participate. Then we have so many people that it was the biggest event ever organized here of a popularization of science here in our city.
Wow.
This is the reason that we are preparing the lunar eclipse from now, the observations of the lunar eclipse from now, because May is near. We have 4 months, less than 4 months to organize this eclipse.
Marcelo, it's nice to see a gathering like this because, we're constantly being bombarded in the news with, conflicts happening where, huge masses of people are suffering because of various, political things that might be happening around the world. And to see people coming together, obviously for joy and peace and to learn more about science and the universe that they live in, this is really amazing. And this is just one of the things that will be your legacy, Marcelo. This is great.
Yes, we celebrate a lot during the observation. Here was the moment that the moon was in total eclipse. Then everybody clapping here. Then we organize a big event. I hope this year, if the weather helps us, we are going to organize a big event also and we are beginning now the organization of this event. And this is our international event that we're helping in April 22, 23. Everybody is invited to visit us. Will be welcome here. If we arrive, everybody that arrives in Brazil, you have place to stay here in our city. We transport to come here.
That's great.
Everybody that comes, that will be very welcome here. And we are trying. We organize even with the pandemic period now, but we hope in April we have conditions to have on-site events. And this is we are planning from now. This is our biggest big event that we organize every year. This is 4 events. You participate here with us. I hope you can visit us again. You'll be very welcome. And this is part of your planning for this year, this first semester after this year. And next week we will begin activities in schools here as part of the project Young Stars of Tomorrow in schools here with the support of the United States Consulate here in Rio de Janeiro. We are visiting schools. Last year we began in October and we visited 19 schools. And this year, if everything happens as we are planning, we are going to visit 50 schools until 50 October. Schools. 50, wow. 50 schools.
That's great.
Schools, until October. We stay during 2 days in each school. Then we will be 100 days in schools until October.
Wow. Wonderful.
No, thank you very much, Scott. Thank you very much, Scott. This, for me, it's ever a pleasure to be here.
Thank you so much. Thank you. That's great. And there we are. Okay. So I want to thank everybody for, I want to thank, of course, our presenters for participating in the 81st Global Star Party, and for our global audience that's watching from Asia all the way out to Europe and down into South America and all the way across the Americas. It's great. I was looking at this map of the lunar eclipse, and we've got a good swath of the middle and eastern part of the United States. I'm glad to say that Arkansas will be in that what they're calling the blood moon on that May 16th. We have many more Global Star Party programs coming up, including one that we'll do from September 21st through the 25th, live from the Oracle State Park, which is a dark sky park in just outside of about an hour north of Tucson, Arizona, and that will be the Arizona Dark Sky Star Party. So we will be offering up tickets to be an astronomer at the event, but it will be a mixed hybrid event where we'll also broadcast the lectures, and we will invite the presenters that normally appear on Global Star Party to be part of it as well, so that we can reach around the world with this in-person event. So kind of an experiment for me to try to host a real star party and to broadcast it at the same time. So that we'll see how I pull that off.
That will be amazing, Scott.
We'll do our best. I'll drink lots and lots of coffee. Okay, so but let me remove this. Here we go. This is those of us that are still with you, but we want to thank you all for participating, and we will. Does anyone want to wrap up and add anything else before we call it a night?
No, as always, thank you, Scott, for making this happen. It's a pleasure to talk with you and with the other presenters and with the people on YouTube and in the other webs that are participating in in every GSP is really funny.
Yeah, this is really great. You know, I was kind of reflecting on, you know, we've done more than 80 global star parties now, and you know, but I see that it's the audience and the presenters. I think that you all y'all are using the internet in the manner it was intended to be used, you know, to bring people closer together. You know, unfortunately, it took a pandemic to really focus us that way. But, you know, we are, you know, we're only a computer screen away right now. You guys have been chatting with us live. We've been interacting with you as much as we can. I hope you really enjoyed the presentations tonight, and we'll be back next Tuesday. Okay, so until that time, keep looking up. Thank you.
Thank you, Scott.
Night,
Good night to everyone.
Stay safe. Clear skies.
Boa noite. Boa noite a todos.